This is Unit 1 review. We're going to do page 2, numbers 10 through 13, and number 16. So 10 and 11 here, it's saying solving algebraically, find the zeros of the following functions. When you're finding the zeros, that means you want to set the equation equal to 0 and then solve. So the first one, we have 3x squared plus 7x minus 6, set it equal to 0. You really have to factor this. The way I factor this is to take that 3 over the 6. So x squared plus 7x minus 18 factors to x plus 9, x minus 2. And remember, we changed this problem, so we have to take it back, divide by that 3. When you do so, you're left here with x plus 3 and 3x minus 2. Remember, since that 3 doesn't go into that 2, you bring it back up to the front. 9 and 3 reduces to that 3. So again, these are equal to 0 since I'm looking for my zeros. So when you set those both individually equal to 0, you get x is negative 3 and a positive 2/3. They are my two answers. Remember, x squared, you should end up with two answers there. Number 11, this is the one a lot of people have questions about. You're setting this equal to 0 just like we did in number 10. All right, what makes this one more difficult is the fraction. Well, when you have something on the bottom, it's being divided, so the opposite would be to multiply. So I'm going to multiply by x plus 1 on the left side and multiply by x plus 1 on the right side. When I do that, it cancels the left side. That was the whole purpose of doing that. You're left with x squared minus 3 under the radical equals, and then remember, anything times 0 is just 0, so it becomes a lot easier. Get rid of that square root by squaring both sides. So you get x squared minus 3 equals 0. X squared is equal to 3. Take the square root, you get x is equal to plus or minus root 3 for your answers there. All right, number 12 and 13, they're asking you to find the zeros, mins and maxes, where it's increasing and decreasing, and then domain and range. It also, in directions, talks about a constant. None of these have a constant, so I just left that out. All right, so zeros is where the x-intercepts are. It's exactly what we just did in number 10 and 11, but instead of doing it from the equation, we're now going to look at the graph. So the x-intercepts are my zeros, so that's right here and right there. So it looks like it's going to be at -1, and we're going to make it 1/2, but it looks like it's between 0 and 1 there. Okay, domain is going to be from -infinity to infinity. That's the far left to the far right. Every x value is included. The range, likewise, is -infinity to infinity. Every y value is included. All right, I like to do the min and the max next. I think that's easier. The minimum is the bottom of the valley, so that's going to be at -1, 0. Maximum is at the top of the hill, so that's going to be at 0, 2. And then we need to find the increasing and decreasing. So that is basically taking your domain and breaking it up into where is it coming up, where is it going down. So this graph starts out going down, so it's decreasing in the beginning, and it decreases all the way to this point. And remember, we use the x value, so that's at -1. Then begins to increase from -1 to the top of the hill, which is at 0, and then it decreases again from 0 all the way to infinity. Number 13, same idea. This graph is done. You should know that this is a right 1 down 2 graph. The zeros looks to me like it's crossing close to 0 and maybe in between 2 and 3 there. Okay, so looks like it's probably actually maybe at -1/2. So I'm going to call this -1/2 and 2.5. Okay, they aren't the exact answers. Okay, but if we wanted to find the exact ones, we could set that equal to 0. That's the general idea as to where they're going through. Okay, the domain there is going to be from -infinity to infinity, far left to far right. Range does not go all the way down to -infinity. There's all these y values that are not included. Looks like to me it's bottoming out there at -2. So this is going to be from -2, and it goes all the way up to infinity. And there's the bracket at -2 to make sure we encompass that actual point. Minimum is going to be, it looks like to me it's over 1 down 2, so that's at 1, -2. There is no maximum there. Again, make sure you write in none, don't leave it blank. This graph is decreasing in the beginning from -infinity all the way down to the very bottom, which remember, if you're using the x values, that's going to be at +1. All right. And then after that, it starts to increase from 1 all the way up to infinity. All right, last one, number 16 on this page. This is asking for f of g and g of f. All right, so I chose this one because this one had an x squared in it. If you're confused on numbers 14 and 15 or 17, remember the answer key is on my website. All right, when you're doing number 17, this absolute value, really all you're doing is taking and plugging it in, so you're going to have an answer with an absolute value, and then you take the absolute value and plug it in there. So again, you'll have an answer with an absolute value. All right, going back to 16 now. So f of g of x. So f of g of x. You're going to rewrite f of x, but you're going to take g of x and plug it in there. So it's going to be 3 times x squared plus x minus 2. You're replacing the x with the new one, dx squared plus x minus 2. And it's still that minus 1, so 3x minus 1. Now we just simplify. So when we do this, this is 3x squared plus 3x minus 6 minus 1. So that's 3x squared plus 3x minus 7. That's my answer for f of g of x. All right, I'll do g of f over here. For g of f of x, we're going to do the same idea, but this time we're going to take the 3x minus 1, the f of x, and plug that in. It's always the second letter that goes in the first one. So this is 3x minus 1 squared plus 3x minus 1 minus 2. You notice I'm always writing in parentheses. I just think that's good practice, especially here. Biggest mistake students will forget here is you have two 3x minus 1s. You need to FOIL that. So that's going to give you 9x squared, and then minus 3x is a minus 6x, and then plus 1. Plus 3x, minus 1, minus 2. So putting it all together, you have a 9x squared, negative 6x plus 3x is a minus 3x. 1 minus 1 cancels, then you just have a minus 2. I just do a quick extension on this problem. If these two were given to you and I was asking for the inverses, whether or not these were the inverse of each other, the answer clearly here would be no, since they both don't come out to be x. So again, when you verify, you do f of g and g of x for whether two functions are inverses. It has to come out to be x. These clearly are not x. So these would not be inverse functions.